Hello friends, welcome to this session. Today we are discussing the elasticity. A body is said to be rigid if the relative position of its constituent particles remains unchanged when external force acts upon it. Actually, no body is perfectly rigid and every body can be deformed more or less by the suitable application of the forces. All these deformed bodies, however, regain their original shape or size when the deforming force are removed. Elasticity is that property of matter by virtue of which a body regains the original shape or size on the removal of the deforming force. When an external force acts on a body, there is change in its length, shape and volume. The body is said to be strained. When the when this external force is removed, the body regains its original shape and size. Such bodies are called as elastic bodies. Steel, glass, ivory, quartz, etc. are the elastic bodies. The bodies which do not regain their original shape or size are called as plastic bodies. Nobody, no body is either completely elastic or completely plastic. If the body recovers completely its original condition as soon as the deforming forces have been removed, it is said to be perfectly elastic. While it completely retains its modified form, it is said to be a perfectly plastic. It must be noted that the deformation in the shape or size of a body is the result of equal and opposite forces or couples in equilibrium. So we can define the elasticity. Elasticity is defined as the property by which a body regains its original position when the forces are withdrawn. When a system of external force acts on a body, relative displacement of its various particles takes place and consequently the body is deformed. For such deformation, the body offers a resistance and internal forces of a reaction are developed inside the body. These internal forces so developed are equal in magnitude and opposite to the deforming forces, and equilibrium is established. The forces of internal reaction tend to restore the body to its original form. On account of the restoring forces, the body recovers its shape or size when the deforming forces are removed. The restoring forces per unit area set up inside the body is called stress, and it is measured by the magnitude of the deforming forces acting on unit area of the body within the elastic limit. Thus, if a force F is acting, capital F is acting on the area, capital A, then we can write stress is equal to F by A. If the stress is normal to the surface, is called normal stress. The stress is always normal in the case of change in length of the wire or in the case of change in the volume of body. The normal stress is of two types. One is the compressive and another is the expansive, that is the tensile. According to, or we can say that according as a decrease or increase in volume takes place, when the stress is tangential, producing the stress is inclined and at an angle theta or at an angle normal to the surface. The stress will have the normal and tangential components. Since the stress is force per unit area and its dimensional is ml1 ml minus 1 t minus 2. The another part is when a system of forces or couples acting upon a body causes relative displacement of its various parts, a change in length, a change in volume, or change in shape produce, the body is then said to be a strained body. So the change in produced in the dimensions of a body of by a system of forces or couples, an equilibrium is called the strain. Or we can simply simple language, the ratio of change in shape or to the original shape is called strain. Change in shape to the original shape is called strain. The change in the change produced in the dimensions of a body by the system of a force or couples in equilibrium is called strain, and it's measured by the ratio of change in length to original length, that is longitudinal strain. That longitudinal strain is nothing but the ratio of change in length to original length is called longitudinal strain, the small l divided by capital L. Another form of the type of the strain is the shearing strain. Shearing strain is defined as the angle of shear measured in radians. If the surface of the surface is fixed and the force is applied here on the top side, and that is parallel to this face, so that the body is sheared by an angle theta. The angle measured in radians is called the shearing strain, that is the theta. And the third part of the type of the strain is the volume strain. The ratio of change in volume to original volume, that is the V by small v by capital V, is called the volume strain. The maximum stress up to which a body exhibits the property of the elasticity is called elastic limit. If the applied force exceeds the maximum stress limit, the body does not regain in its original position completely after the external forces are withdrawn. Thus the strain is just a ratio or an angle. It is a dimensionless quantity and has no units. Now we discuss about the Hooke's law. This is the basic law of elasticity and was established by Robert Hooke in 1678. This law states that within the elastic limit, the stress is proportional to the corresponding strain. Or we can write the stress is equal to A into strain. Or we can write A is equal to stress by strain. Here the constant of proportionality E is called the modulus of elasticity. Its value is independent of the magnitude of the stress or the strain and depends only on the nature of the material and its other conditions. So the modulus of elasticity has the same dimensional formula as that of stress, that is m l raised to minus 1 t raised to minus 2. Since strain is a dimensionless quantity, corresponding three types of the strain, we have three moduli of elasticity, namely as Young's modulus. What is the Young's modulus of elasticity? It is defined as the ratio of normal stress to the longitudinal strain, as we know the normal stress is equal to F by area, that is the force per unit area, and the longitudinal strain is change in length divided by original length. So by rearranging we get the Young's modulus is equal to F dot L divided by A L. Another type is the bulk modulus. That bulk modulus is nothing but the ratio of tangential stress to shearing strain, that corresponding to volume strain. So we can write eta is equal to tangential stress by shearing strain. Tangential stress is nothing but F by area and shearing strain is theta. So by rearranging we get the bulk modulus is equal to force per unit area with their shearing angle, that the shearing strain. And third one is the modulus of rigidity. Sorry friends, here this one is the modulus of rigidity, and now I am expressing the bulk modulus. So this eta is nothing but the modulus of rigidity, and now I am describing the bulk modulus, that is the normal stress divided by volume strain. The normal stress is nothing but the force per unit area, and the volume strain is V by capital V. So we get FV by small av, so PV by capital V, and where P is the change in pressure. So if we are taking the reciprocal, that is the compressibility of the modulus of elasticity. So these are the basic introduction of the elasticity, stress, strain, Hooke's law, and the model of elasticity. I hope you understand. Thank you for watching this video.